Okay. Today we are going to talk about some simple mathematical models, physical models for phase transformation kinetics, for to describe how fast, which is kinetics for phase transformation or some related chemical reactions. Okay. So before we go there, let's first look at the two common types of data curves that one may encounter in the study of phase transformation. We call the first one called TTT curve, the second one called the CT or conversion time curve. The first TTT curve is essentially T temperature, T time, T for transformation, the 3T curves, TTT curve. And typically, the TT curve will look something like this plotted on the right. The vertical axis T is for temperature. The horizontal axis T is for time. And typically, the horizontal axis is in the log scale. And it's a series of curves that represent the extent of transformation, as I illustrated here. For example, one curve is for the 1% of transformation, going from the existing phase to the new phase. While another curve, for example, could be this 99% transformation curve, which means the transformation is largely finished when reaching this curve. So this is TTT curve, and typically it's, as what we illustrate, a series of curves for different extent of transformation or conversion. What we showed on this plot is the curve for 1% transformation, 99% transformation. In experiments or in literature, researchers you may come across other external transformations such as 5%, 95%, or 50% for etc. Okay, so it's a series of transformation curve. Each curve represents the same extent of transformation. Okay, with vertical axis of temperature, horizontal axis of time. And as you can see from here, they are typically so-called nose-shaped that sticks out in the intermediate temperature range. And it takes longer time at higher temperature and also longer time at lower temperature. Okay, so how do you generate this curve? Typically, it's when you do quenching for the sample to the temperature below the TE, which we call equilibrium temperature, and then quickly quench to a certain given temperature and then hold. For after a certain time, you analyze the sample. For example, it reaches 1% transformation by phase analysis using X-ray or morphology analysis using ICM or some other mechanism. And then you hold it longer, the extent of transformation goes higher. For example, up to here, it may reach 50% transformation. And then you hold it for even longer, you may reach 99% extent of transformation, which means at this point, after this temperature, when the time is here, the transformation is essentially finished. Of course, you can do that at a different temperature. You quench to an even lower temperature and then hold certain time. You reach 1% transformation. You hold it for much longer. It reaches 99% transformation. But as we mentioned, these TTT curves are a series of curves for different extent of transformation. Each curve represents the same extent of transformation or extent of conversion, and quite often they are nose-shaped. Okay, when they say nose-shaped, you can understand that as at the very high temperature, when are very close to the equilibrium temperature, and what you learned before, they would have lower undercooling and a lower driving force, for example, for solidification or for precipitation types of transformation. On the other hand, at a very low temperature, when you quench it to here, let's say, okay, then it also takes much longer to reach 1% transformation or much longer to reach 99% transformation. The reason being it's in solid state, we're blaming slow diffusion. It is only in the intermediate temperature range that such pure solid precipitation type reaction is fastest. Okay, you reach the high transformation, low transformation in shortest time, and high transformation in also shortest time. Okay, these types of nose-shaped curve, people quite often call them TTT curve. Temperature, time, and extent of conversion. Remember again, each curve represents the same extent of conversion. For example, this solid black curve is for 1% transformation, while this one will be for 99% of transformation, which means largely finished. Somewhere in the middle, you may encounter 50% transformation. Okay? And generally, people often get this TTT types curve for reaction happening during the cooling process, with undercooling and typically for solid state transformation. The other types of kinetic curve that you may often come across is so-called conversion time curve, or CT curve. C for conversion, T for time, conversion time curve. And in this curve, it's mostly also for isothermal condition. You get them mostly for isothermal condition. Here we show vertical axis showing conversion or extent of conversion, extent of transformation. And the horizontal axis would be for time, also often in log scale, but it can also be in linear scale. Okay? And then quite often, the shape of those curves would be so-called S-shaped, especially when the time is plotted in logarithm scale. Here we show a S-shaped curve for temperature, let's say T1 for the red curve, and then you may get the quenching experiment conversion done in a different temperature and get another S-shaped curve, roughly S-shaped curve, as what we show in this blue curve for T2. Okay. So such S-shaped curve is quite often called the conversion time curve or CT curve. And the T1 curve in the CT curve may correspond to a isothermal temperature, let's say T1, in the TTT curve. And then 1% conversion roughly corresponds to here, very low extent conversion, while 99% conversion roughly corresponds to here, with high extent of conversion. And similarly, if it's for precipitation, the T2 curve may be happening at a much lower temperature with 1% extent of conversion corresponds to roughly here. It takes much longer time, while 99% takes even longer time here in the time scale. But the conversion is very high, close to 99% here. Okay? And the CT curve can be for many different reactions. For example, they can be those that occur with undercooling, such as precipitation, but they may also occur for reaction of phase transformation with so-called superheating. Okay, and we can talk about those later. On the other hand, the TTT curve, primarily people use them for precipitation types of experiment happening with undercooling. Okay.